I am purposely going to back up and redo the last thing that we worked on, basically, which was this derivation of an Excel exercise and derivation of how we calculate basic statistical functions using basically just math, using Excel, but we're really just using math on Excel. And so that you can understand where these things come from. So this is descriptive statistics for numerical variables. A lot of times you're going to be spending a lot of time working with numerical variables because people like to measure things. That's what we do. That's what we do these days. We measure everything. We measure hits. We measure blood pressure. We measure blood sugar. We measure numbers everywhere. So there's a lot of application for this. So that's why we're starting with numerical variables. Again, last week we talked about the importance of understanding what kind of variables that we work with, because it's important to understand that use different statistical techniques, different graphical techniques for different kinds of variables. So for instance, now numerical variables, we're going to be interested, when we collect a sample, we're going to be interested in how spread out are the values, how variable is this sample. Why are we interested in that? Because we're not really interested in the sample. We're interested in the population that it represents, but our only window on that is the sample. So we want to know how variable, how spread out. If we have blood pressures that are all between 90 and 110, or do we have blood pressures in this population that go from 50 to 250, right? That's going to be important to us, how spread out it is. We're also going to want to have an idea of where the middle value is, where the center is. Is the average blood pressure, is it 80? Is the average blood pressure 90, 100, 120, and so on and so forth? So we're very interested in where the center is, and we're very interested in some measure of the variability or the spread, how spread out the data is. Okay, so, and we started with these 10 numbers. So I'm just going to go through quickly how we got, what specific ways we have of measuring the center and the variability. Okay, and I'm going to start with the simplest of these, and that's like the average, right? The arithmetic average. So we have 10 values here. Maybe their ages, maybe their heights or something like that, right? So I'm going to take those 10 values, and I'm going to calculate where the middle of that is. Well, there's a number of measurements of middle that I can use, right? One of them is the median, the middle value out of these 10 values, right? So one of the ways I could do this, I just could highlight these. Now, again, for you guys that are not that familiar with Excel, what I'm doing there is I'm clicking down on the first box, holding down. I'm not lifting or my finger. I'm still saying click down, and I'm dragging down to the bottom number. And then I'm going to say copy, and you can say Command C on the Mac or Control C on the PC for copy. And then I'm just going to go over here to some random box over here, and I'm going to say paste it there. Again, you could just say Control V, or oops, did that not work? Paste. I guess they didn't really copy it. Okay, I'm going to say copy, and I'm going to go over here and say paste. I'm doing this because you can see me doing it visually. If I hit Control C and Command C and Command V on my Mac, you're not going to see me do that. So I'm just using the menus to make it more obvious to you. Okay, so normally I would probably just use the shortcuts. So okay, so now I'm going to take this data. I'm going to go over here to this. We got tools, we got data. One of the functions in data in Excel is sort. Okay, now it's different versions of Excel. For instance, on the PC version, you can find sort in one of the ribbons. You don't. In fact, on the Mac, you can also find it somewhere in the ribbons also. But I just happen to have it up there, and it's handy, so I'm using it that way. So I'm just going to tell it to sort that column of numbers. Well, now that I've sorted that column of numbers, I can see that there's 5 of the lower values go up to 49, and the 5 higher values start at 49. So the middle value, in this case, there's 10 values. There is no middle value. The middle value is between 49 and 49. If those were different numbers, I would call the middle value the average of those two middle numbers. If you have an odd number, a sample with an odd number, you'd have half below, half above, and you'd have a middle number all by itself, right? You'd really have a center. So I'm going to call the middle number 49, the middle of this 49. That, in terms of statistics, we have a couple of names for that. One of the names for that is the median. I'm going to say it's equal to that 49. Or I can also say it's equal to the function median, parentheses, and then I'm going to highlight, click down, drag, and tell it find the median of A2 through A11. That's the median value. Another name that we have for that is the 50th percentile, right? Like when you took the GREs or SATs or PSATs or whatever standardized test that you've taken, whatever of the 8,000 standardized tests that you people take these days. Right? When I was your age, I think they had something called Regents. Took a few Regents like history and stuff like that, and they had SATs back then, but that was pretty much it. You know, nowadays you guys are getting tested every like 6 months or something like that, and okay, hire and fire teachers, open and close schools, based on all these statistics, based on where the middle value of your reading score is. You know, these numbers have a lot of impact, right? So it's 50th percentile. That means 50% of the sample, 50% of the people who took the test in your case are below that number, and 50% are above that number. 75th percentile, 3/4 are below that number, 25% of the people are above that number. Okay, so we'll talk about that in a second. So the middle value is the median. We can also look at the arithmetic mean. Okay, often when we start talking about normal distributions, often the median and the arithmetic mean are the same, are pretty close to the same number. It may not be exactly the same, but it's unusual for them in most of the kinds of data that we collect. It's unusual for them to be very different. And if they are very different, that's an issue for us. And we'll figure that out in a second. So how do we figure that out? Well, first of all, how many values here? I'm going to click in there, equals, count, right? There's 10 values there, but there is a function called count I can use. Equals, count, and hit enter. Okay, and again, you guys remember that I'm gonna put a total here, total for all values here. I don't have it here. Equals sum. There's a function sum, and you guys know from last week that if we had the equal sign, that if we saw an equal sign, that means I'm about to put in a function. I can start typing it, and SPSS, Excel gives me a bunch of functions that start off with that sequence of letters. Sum is the one I want, and then I can, after a parentheses, open parentheses, it gives me a hint, sum, and then in the parentheses put the list of numbers that you're going to find sum of, which I'm going to do now. Okay, some of these numbers from A2 to A10 turns out to be 500. So the mean, the arithmetic mean, there's two ways for me to figure that out. One way is to just take the total and divide by the count, 10, and I get 50. Another way is to use a function in Excel, which is the arithmetic average, which is the mean. They don't call it the mean for some reason. They call it the average. I'm not sure why they do that. Even in the statistical sections of the list of functions, they refer to it as a mean, but they call it, they type it in as average. So it works both ways. It works same either way. Does the same calculation for you. Those are a couple of our measures of where the center is. Anybody remember another one that we talked about last week? How about the most frequent value? Very often the most frequent value is also in the middle, right? It's also around 50. That's called a mode, M-O-D-E, parentheses. And oops, I left out the equal sign, so it didn't pop up suggestions for me. There we go, so mode. So the mode is the most frequently occurring value. And I'm gonna guess that that's probably gonna be 49. See if it is, and it certainly is 49. That's the mode. Okay, so there's several different ways to describe the center of this distribution in numbers. Now let's talk about variability. The absolute simplest way of talking about variability is just look at the lowest value that you collected and the highest value you collected. The lowest value you collected was 39 inches. Let's say I'm using inches for, or I'm calling them heights for argument's sake. And the highest value, maybe this is the heights of, let's see, 60, that's 5'1". Maybe this is heights of 14-year-old males, 13-year-old males. So the shortest person was 39 inches, tallest person was 61 inches. And so the minimum value is 39, maximum value is 61. The difference between those two is called the range. How many inches difference between the smallest value and the highest value is the range, which is a great way to describe variability because it really gives you that length. Okay, now if I had, instead of 10 numbers, which I could sort and look at very easily, if I had 10,000 numbers, I would want a function for that. And in fact, there is a function equals min, parentheses, for the minimum value. I'm going to use this one over here because it's the same set of numbers. And the minimum value is 39, of course, and the maximum value, max, parentheses, maximum value of a set of numbers, which is I2 through I1 through I10. The maximum value is 61, as we said, and the range is equal to the difference between the maximum value, minus the minimum value, F4 minus F3. 22 inches is the difference. That's the spread of the values that we have. I don't think there's a range. Nope, that's for binomial distribution. Don't worry about that. Okay, so forget you saw that. That's a different kind of function. So that's one way of describing. Now I mentioned that the idea that this median, right, middle value is the 50th percentile, half below, half above, right? Well, in fact, one of the things we might be interested in is, what about the middle 50%? In other words, maybe this person that's the shortest person in this class is unusually short. Maybe the tallest person in this class is unusually tall, and then like most of the other people are pretty close to the same height. That happens a lot, right? Probably might happen in this class. I'm not gonna make you all stand up to figure out who's the shortest, who's the tallest. So that happens quite a bit, where we get a lot of people in the middle, but we get fewer and fewer people as we go further out from the middle. So the range kind of distorts our idea of what's the spread in this data. So it might be nice to have a measure of where is the middle part of this data? Where are the middle 50% of these people? So we break up the data into quartiles, the 25th percentile, the 50th percentile, the 75th percentile, and of course 100th, right? Everybody, the tallest person. So we're going to look at what's not just the range from 0 to 100%, which is what we call the range to start off with, but we're going to look at another type of range, which is where are the middle 50% of the people, 25% below the mean and 25% above the mean, and median rather. Where are those people? Well, those people are called the interquartile range, right? And we're going to calculate that right now. But in order to calculate it, I don't think there's a function for interquartile range. No, there isn't a function for interquartile range. I know there isn't, but I'm just testing it. Okay, so what about just determining percentiles? And there is, in fact, a function for percentiles. I'm going to type it in, equals percentile, open percentile, open parentheses. Let me just make sure everything's muted here. Okay, open percent, and when I hit that open parentheses, it gives me a hint. It wants to know two things: percentile, open parentheses. It wants to know the array of numbers, the list of numbers, and it wants to know some value k. If I were to click on this and open up the help function, it would tell me that k is the percentile as a decimal point, 0.75 in this case. Okay, so what am I looking at? I'm looking at the array 39, 39 through 61, comma, 0.75, close parentheses. And I'm going to hit enter, and it's 53.8. Kind of an odd number, right? It's none of those numbers are actually there. It does a little thing here where it's kind of figuring out if this were a population of people, where would those heights actually be? Remember, these numbers are really, it might be 39 inches, but they're on a scale. So 39 inches might really be 39.1 or 38, 38.7 or something like that, and rounded. Same with blood pressure. Same with blood sugar. Even though they look like they're discrete numbers, like integers, they're really on a scale. We just round them. Okay, tend to round. So let's try the 25th percentile. It's equal to percentile, and this time we're going to get the array again, comma and 0.25, comma and 0.25. Okay, 48.3, and the difference between those two, 53.8 minus 48.3, difference between these two is the interquartile range. Everybody okay with that? Right? Okay, good. Okay, so, well, that's real nice. Except now, you know, one of the issues that we're going to have is that when we get many of the measurements that we're going to take are going to display a certain characteristic about the way that that the numbers distribute themselves, and that is the middle height is, say, in this case, 50 inches. However, half the people are below 50 inches. We saw with the median, half people above, half people above. Let's say that that's the population. When we take a sample of those people, right, and we make a bar chart out of that, we're going to find that most of the people are going to be close to 50 inches, right? As you get further away from 50 inches, we're going to have fewer and fewer people in our sample, even in the population, that are that particular height. And you're going to have very few people that are below 39 inches and very few people that are above 61 inches. So these kinds of numerical, when we go and randomly pick people from a population, these kind of, the sample that we wind up with is very dependent on chance, because our intent is to randomly pick people from this population. And what we notice is that more of these people are in the middle, fewer and fewer as we get further away. We get fewer and fewer people as we get further and further away from that middle or average or median value. So instead now, we need another kind of measurement here, a measurement that takes into account that odd-shaped distribution. The bar chart that we create is going to be tall in the middle. It's going to be shorter bars as we get to the outside, shorter and shorter bars. If we took a big enough sample, we had enough bars, those bars would smooth out so that they form a bell-shaped curve. And I'm using that. I usually try not to mention this word until another week or two, but that's something called a normal distribution. That's when the measurements are random, when your sampling is random and the effect is random, then we tend to get something called a normal distribution, that kind of specific distribution. We need a measurement of that property. What's the spread? Now, it's nice to know the range. It's nice to know the quartiles, but it really doesn't tell us anything about the nature of how that bell-shaped curve is spread out. Is it wide and flat? Is it tall and narrow? Right? We don't really know that yet. Some distributions where there's not much difference between the mean and the other values are very tall and very narrow, but they're still bell-shaped, right? Some distributions are very spread out, right? The height's not very high, but you can still recognize it as a bell-shaped distribution. So we need a different kind of measurement for that. So that measurement turns out to be these terms called the variance and standard deviation. Variance and standard deviation, and even one of the other steps we go to get those numbers, called sum of squares, those are going to be important numbers to us. They're going to describe the variability in a normal distribution, which is very often what we're working with, the specific kind of distribution that we're working with. So how do we get to that point? These are the functions: sum of squares, variance, standard deviation. How do we get to that point? Okay. So those of you that were here last Monday, which was Thursday, which was 2 days ago or 4 days ago or whenever the hell it was, right? You might remember that we had gone over. I just want to cement this by going over this once again, and also just to repeat some of what we learned about SPSS, about Excel. So I'm going to go now and I'm going to figure this out. I'm going to figure out what these values are, and you'll see in the process how they're calculated. Okay, so first thing I'm going to do, well, you know what, I'm going to do 2 in the background. I am going to open up a blank sheet here that I can write on. I don't have to be that big. So I can resize it and move it over. Okay, and I'm going to start by taking the mean, and I'm going to subtract the mean from each value in this sample that the mean was derived from, right? So I'm going to go here and I'm going to put in the mean, which is 50. Whoops, hit enter, it's 50. Now I want to copy that down. The only problem is we know that if I copy it down, it's not going to work because SPSS, because there's columns here, is going to advance the cell. It's going to, instead of put 50 in and then 49, then 10, and so on and so forth. So I got to make sure it copies just that number itself. So I'm going to put a $sign in front of the B and a $sign in front of the 13, and that changes that from relative addressing, which would progress, to absolute addressing. In other words, if I copy this down, just copy down the same cell or number. Don't go advancing the cell. And it copies it. It's 50 now. Okay, so that helps. I have X bar here. Okay, so X bar means the mean, right? I can't, in here it's hard for me to draw X with a bar over the top, but if I were writing it, which you'll see me do in a second, that's the way I would write it. Why do I put X bar instead of mu, the Greek letter mu, which also means mean? Anybody remember why? What's the difference between X bar and mu, since both of them are the mean? Why would I use one and not the other? Mu is used when you're talking about the mean of the population. X bar is used when you're talking about the mean of the sample. From now on, if you're talking about the mean of the population, always use mu. That's a Greek letter with looks like a little u. When you're talking about the mean of a sample, use X bar, X with a bar over the top of it. Okay, similarly, we're going to talk about other functions as well. That's similar. When you're talking about the population, using a Greek letter. When you're talking about the statistics, the collection of your sample, I use, what would you call those? English characters, I guess. Are they really English? They have another origin, right? Arabic or English, whatever, right? The typewriter characters. I'll call them that. Okay, so at any rate, and just as a reminder, we call the Greek letters that describe the population, we call those parameters. Mu, the mean of the population, is a parameter, right? Sigma, the standard deviation of the population, is called a parameter. Meanwhile, on the sample side, X bar, the mean of the sample, is a statistic. SD, for a standard deviation, right, is the standard deviation of a sample, right? Is a statistic, again, parameter versus statistic. Okay, so now we got that squared away. Now I'm not beating that to death. Okay, let's look as a measure of variability from the mean. How far? Remember, again, when normal distribution, we're interested in how it distributes around the mean, right? So the mean being the center, the high point, for our histogram, right? So how far from the middle are each of these values? So I'm going to calculate the value X minus the mean. And for each value, I'm going to then go over here to the corner. You can either highlight and pull down and go up here to edit and say fill down, right? It'll do it since I'm using relative addressing, I didn't put a $sign. It's going to fill each one of the values. It's going to fill the formulas down, not the actual number. And you can see these numbers, some of them are positive, some are negative. So now if I want to get a measurement of the total variability here, the difference between some of the differences between X and X bar, if I take the sum here, I got a problem. And I'm always unhappy that this is what this is going to do. It's an anomaly in this silly program. It's because you're using a device that can only talk ones and twos to do continuous numerical variables. So all came up 0 this time. Sometimes it comes up, 1 times 10 to the minus 27th or something like that, right? But it came up 0 this time, so I'm happy now. Okay, they cancel out. So we can't use that as I add those together to measure the spread here. So wait a second, what did I just do? What I just did is I took, oh, am I here somewhere? Come on. Maybe I'm not turned on. Oh, there we go, I think. Oh, there we go. Okay, good. What I just did here was I took x minus x bar, but I did it for every value. I took the sum, right? This Greek symbol represents summation, sigma represents summation. I took the sum of x minus x bar. So I took all of these individuals, x's minus x bar, from n equals 1, first value to the 10th value, to the last value. Okay, so for each one of these values, I took each one of these differences, x minus x bar, and I added them all together. And that's what came out to be 0. So now I'm going to go back here and say to myself, well, gee, that doesn't work out for me. I need another way to measure this. So I'm going to take each one of these values and I'm going to square it. I'm going to take that and multiply it by itself. And I'm going to repeat it for each one of these cells. So now I've taken each value and I've squared them. 4 times 4 is 16. Now they're all positive values, right? So now when I take the sum of all these values, I actually get a number that's not 0. And I also get a number that if my original differences are bigger, then the squares will be bigger. So the total is going to be bigger. So it has some relationship to the spread from the mean. So what have I done now? I've just taken x minus x bar, squared it, and added those all together. That now is called sum of squares, the sum of the squares. Also, more appropriately, it's the sum of the squares of the differences, but in statistical shorthand, people call the sum of the squares, right? So sum of the squares is 326. Now, I want to look at the variability for each individual value. So in a sense, I don't want the real sum of all the differences. I only did that because I needed to get rid of those negative values, right? I really want kind of the average variability for each of the values. What's the average x bar minus x bar squared? What's the average? Okay. Well, the way I'm going to do that, I'm going to say it's equal to the sum of squares divided by the count, 10. For statistical reasons, for reasons for the moment only known by the gods of statistics, instead of using the count n, the total number in the sample n, right? We're going to use n from now on for the count. Instead of using n, we're going to use n minus 1. Instead of using 10, we're going to use 9. So what we're going to call the variance is the average sum of squares, right? It's the average of the sum of squares. Okay. In other words, the variance. I'm going to divide that by 9, and that comes out to 36.2. Okay, what have I done here? Well, I've taken this and divided by, over n minus 1. Okay, that sounds pretty good, right? So now that is my variance. That's called the variance. I'll just put VAR for now. So what am I going to do next? Well, that 36, that's the average of the squares, of the differences of the squares, squared. Well, but yeah, see, so look at 36 is a big number compared to what the differences really are. So to bring it back down into the range of numbers that are real life for this distribution, I'm going to take the variance and I'm going to find the square root of it. So I'm going to click in here, put an equal sign in here, and I'm going to use a function sqrt parentheses. And I am going to click in here for 36.2 and find the square root of the variance. And that turns out to be 6.0. So what have I done there? I've taken the square root of the sum of the squares divided by n minus 1, which is the variance, and then I find the square root of it, and that's called the standard deviation. Okay. If we were talking about the population, we would use sigma. If we're talking about the sample, like we are in this case, we usually just use S, small s, SD, right? We use anything but a Greek letter, right, to describe it. That's sigma, that's the standard deviation. Very important information for us. We're going to see in the future being like the next week or a couple of weeks, we're going to see in the future that when you know X bar and when you know the standard deviation, the X bar approximates mu, the standard deviation approximates the standard deviation of the population, sigma, and this will give you a good idea of how this population is distributed, how the real, what this bell curve for this population really looks like, which we're going to have, we're going to have all sorts of utility based on knowing these two numbers. That's why they're so important. That's why those particular numbers are particularly important. So we fill everything in here. Okay. So now I'm going to take these numbers and we're going to take a look at how you're going to do this in real life. Well, in real life, you're not going to go through all this, right? We just did this for the SPSS practice for other reasons as well, you know, to acquaint you what these numbers mean and so on and so forth. And, you know, I'm for those of you that really have gotten this, I'm sorry to repeat it, but I think it's worthwhile for a lot of people that I don't want struggling right at the beginning. Okay, so instead of going through all of that, meet the average, parentheses, oops, parentheses, there's my mean. Here's my median. Oops. Here's my standard deviation. Here's my variance. I'm having problems with my trackpad here. Here's my variance. Here's my standard deviation. Of course, my standard deviation is going to be pretty close to 6. I'm not sure why that came out different. I think because I didn't, my stumbling with my keypad here screwed things up. Before it came out to be 6, I think, right? So I did something wrong there. B1 through B10, maybe copying the numbers. I don't know what I did. That doesn't matter. Okay, so at any rate, that's really how you're going to calculate your values. You're also going to consider using SPSS for doing this as well. So now I'm going to give that a try right now. So I'm going to take the same set of numbers. And you know, I don't think, you know, I've been waiting for them to update the licenses on SPSS, and I think my SPSS has expired. It runs for a while even after the expiration date, but I think I've run out of time. I've been waiting for an update on the license from the School of Public Health for the instructors, and nope, not gonna, nope, it's expired. I'm not gonna be able to do it on here. I'm gonna move over to the other computer, to the lab computer. And the reason why, you're probably saying to yourself, what a cheapskate. Why don't you just spend the 35 bucks like we have to and do this? Unfortunately, they know I'm an instructor. So the cost of the license for me is $200 or $300. So I tend to wait until they give me the license. And they're slow this year. So I'm going to use the other, I should have it by the next class, almost certainly. And in fact, up until a couple of days ago, it was working. So that combination of timing and lack of timing kind of cause a problem here. Okay, so I'm gonna take these numbers and I am going to move over to, so let's see how I'm going to do this. Let me check. You guys online? I don't see anybody typing in the chat box that I've said anything that's caused any consternation. If I have, let me know. And make sure it's still muted, and let me change the presenter. This might be a problem because I don't have a microphone on there. Okay, so let me summarize what I'm about to do for you guys that are online. I am about to start up SPSS. I'm about to start up SPSS on the PC that's here in this room, the computer that's here in this room, instead of on my Mac. I'm going to have to make that computer the presenter temporarily. Problem with that is that the instructor's PC here doesn't have a microphone on it. So what I'm going to do is I'm going to unmute myself on my Mac while still using the PC, while using the PC as presenter instead. And I'm hoping that you guys will still be able to hear me, that you're online. The people here in the class are not going to have that problem, because unless when I mute my computer, their air's shut off, they're not going to have an issue with this. So I'm going to make that the instructor. Okay, so as of right now, you probably can't hear me. Those guys online. Or maybe you can, because I see my microphone is still on. Can you guys hear me online? Oh, good. Okay, so that solves that problem. Now we just have to figure out how I'm going to work with the microphone on my Mac and with the screen behind me, which is not really designed to work as a computer at all. And if I confuse you guys, you guys know what's going on here, right? Okay. Oops, I should have said share. Where is share? Oh, maybe I have to do this again. Okay, I'm back to me. Let's try again. Okay, this time, share. Okay, that seems to be working up to now. So let me get the data on here. Oops. Let me get that computer closer to me so I can be heard. In case you're wondering, my name is misspelled, but rather than risk them erasing like 18 of my courses, I have never asked them to like correct the spelling. I'm sure you understand why I say that. They tell me they can fix it, but I don't want to chance it. Okay. You don't need to share this. Oh my goodness, a login error. Okay. Try this again. Okay, let's try this. Eureka. It worked. Yep. Okay, so where is... Nope, that's not what I want to do. I'm in unfamiliar territory here. Where are my courses? Announce. Oh, here we go. Okay. And I'll go down here. See if anything happened here. It doesn't look like it. Okay, let me get things out of the way here. Not sure why I can't get up to that window. Okay, hopefully. Whoops, I shouldn't have closed that window. I have to go back and get it. Oh, I get it. That's on my PC. I think. Maybe not. I think this is the PC window. Okay. Now I understand what's happening here. I should see the mouse down. Yeah. That's my Mac mouse. Oh, can you see? Oh, I'm looking at the wrong screen. I guess you can't see my mouse when I'm doing this. Didn't realize that. Yep. Okay. There it is. That's what I'm after. Okay, I'm going to open up that same file again that we were just looking at, except I'm opening up on the PC. And I'm just opening it so I can copy those numbers. Then I'm going to open SPSS from scratch, just blank version of SPSS. Hopefully they've updated the licenses here. Okay, here's our numbers. I'm just going to go down here, and I'm going to say, for argument's sake, I'm going to use Control C to copy it. So I don't have to go searching for it on the PC. Okay, I got those. The guys that do a lot of graphics work and stuff like that, they call those marching ants. You know, that kind of like perforated movement. So I'm going to copy the area inside these marching ants, and I'm going to minimize this, get it out of the way. Whoops. I can't tell which. Actually, make that even again. I'll close it. And I'm going to start SPSS. Did we see it here? Here it is. I'm going to start up SPSS. Once SPSS starts up, it'll come up with an introductory window at IBM SPSS, a little bit of a slow startup. It's a big program, big, bulky program that they've been updating to version 25 for years and never is rewritten from scratch. So hence it's got a lot of detritus in it. So it's a kind of a slow, lumbering program. It does the statistics very quickly, but saving, opening, closing, saving files and stuff like that, it's remarkably slow like it is right now in opening. If you want, you guys can open this also. If you want to mirror what I'm doing, all I did was copy those, open that Excel file from Blackboard, copy those 10 numbers. You can even just type in the 10 numbers when the time comes. Okay, this is really cooperating here. So I should be able to see this on here somewhere. Hasn't opened yet. Let's try this again. What's that? Oh, it took a few minutes on your machines also. Jeez, I know that. Consider starting up sooner. Okay, as this is taking whatever amount of time it takes, one of the things I'm doing here is I'm going to start up SPSS. We're going to see a window open up. It says IBM SPSS with the version number and so on and so forth. Once that's out of the way, I can click, that'll disappear. Another window will open up, and especially if you've just installed the program. That's kind of a window that allows you to navigate through recent files that you've used to different areas of SPSS, different functionality of SPSS. Kind of when you first open Microsoft Windows and you get that window that shows you a bunch of templates, and you can choose, let's say you just want a blank piece of paper, it forces you to choose a template. I see it's opening up now. It forces you to choose a particular template, right, where you just want a blank piece of paper. In that box, I'm going to click in this just to see if it'll help move things up. Oh, there we go. They've turned it off, so you didn't see it here. In that box, if it appeared on your machines, and it will when you first start it up, in that box there's a little checkbox in the corner that says if you don't want that to show up, just like if you don't want the templates to show every time you start as Microsoft Word, you can check that box, and the next time you do it, that box won't show up. Okay. Instead, it'll open up just as it did here to something that looks like a spreadsheet, right? It's got columns, it's got rows. The rows are numbered, just like in Excel. The columns don't have letters in them. They have, each one of them says VAR, 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 and so on and so forth. The reason for that is that this is not a spreadsheet. If I were to click in here, it's really a database. It's really a data storage device. If I were to click in there an equal sign, I gotta remember which keyboard to use, If I click in there an equal sign, all I get is an equal sign. I don't see anything else happen anywhere here. So I'm going to get rid of that. Okay, so these are just storage cells, right? These are just places to store information. That information could be a number, it could be a word, it could be and so on. So what do these rows and columns mean? The columns represent variables. So for instance, let's say you did a study and involved the same 15-year-old, 13-year-old male students, and you took a random sample of 10 students, and you measured their height. This first variable would be where you might list your height, okay? And you would change this from VAR to whatever you want to call that variable, like height might be a good thing, right? And each row represents a subject. So in our case, if I click in here and hit paste, Control V, a miracle, there's my data from Excel. Okay, you'll notice that it added a couple of decimal places and stuff like that. You'll see why that's the case in a second. It filled in the data that I just that I collected on those heights. Well, now maybe they're not all boys, maybe they're boys and girls. I could, in this box, I could put the variable male, or gender, and I could say male, female, female, male, female, female, and so on and so forth. Okay, in fact, I may do that in a second, just to demonstrate something else. So this box represents all the different heights. This is the variable height. Gave it automatically, when I pasted it in, I didn't tell it was height, so it gave it a default name of VAR 0001. Okay, so now I wanted to use the variable that I wanted to use. I want it to be called height, that variable. If you go down to the bottom, you see two tabs down there. You see data view, which is highlighted right now, the data view. Okay, you see variable view. I can click on that. It's going to change the view of this storage device, this table that I have in this SPSS, or file I haven't opened in SPSS. If I click on that, it goes to a view which describes the variables. In this case, each row represents a variable. So if I go back to the data view, I see that I only have one variable in this collection of data. But when I go to the variable view, there's only one line because there's only one column of data, only one variable. So I can click in here and I can change that name, which I'm going to do right now. And did I spell it right? Oh, no, I didn't. Good enough for government work. I'm not going to change it, right? So here's the misspelled height. Here's my misspelled variable. Maybe maybe it's a tool for it. I'm going to leave it that way, right? So what are the rules here for naming variables? Variables can only have alphanumeric characters, can only have letters and numbers. They have to start with a letter. They can't have any spaces or special characters, no asterisks, no slashes, anything like that. Only letters, numbers, got to start with a letter. And it used to be they could only be, I think, like 9 digits long in the early versions. Now, I think the sky's the limit in terms of length. But they can't have any spaces in it. Because they can't have any spaces, let's say that I gave it the variable name HT, just because I was busy that day and that's what I called it, right? Well, that's not very descriptive. When I work with SPSS, it's going to allow me to put together very nice tables and graphics and so on and so forth that I'll be able to print out, or even better yet, copy and paste into Word documents, for instance, if I'm creating a report, or into PowerPoints if I'm giving a presentation, right? So I want it to be a little bit more descriptive, but I named it HT maybe to keep it in compliance with some other database I'm working with, so I know that it matches that variable. But in our analyses, we want our charts to be more descriptive. So I can go over here, go to the right, and let's see, it's a numerical variable, which means it's mostly numbers. You can see if I clicked in there, you can see all the various choices you have for that. If I said string, like letters and stuff like that, then I wouldn't let me put numbers in there. So I don't want that. I'm just going to leave it numeric, right? And you'll notice that the width of the characters that I can have in there is 8 characters wide, So the heights are only 2 digits, right? So I'm not 8. The 8 is overkill. That's fine. And notice, remember, it changed everything from 49 to 49.00. That's because by default, it assumes 2 decimal places, right? I could change that to 0 if I wanted to. I'm going to leave it like that. The next column I have is label. What I can put in there is a description of the variable, which I have spaces, I have special characters. I can fully describe the variable, and it will use the label in labeling the charts and the graphs instead of the variable name. We'll still be using the variable name for various purposes when we do the operations, but when we produce the output, it'll use that. So I am going to put in there height before E, height of boys. I'm sorry, no, oh, thank you very much. Height of boys, oops, boys. I don't even know what, yeah, boys. Yeah, well, that's like, maybe it is. Maybe it's the height of sea boys, ocean faring boys, right? I didn't say it wasn't. Yeah. I still got height again. Don't apply the rules. Okay, so it's going to substitute that label for anything that we do on the charts. Now, I'm having a senior moment here. That's spelled wrong, right? Oops. I need to get rid of what I just did there. The more you think about these things, the weirder it gets. Let me correct that. It's annoying. Is that right now?
Uh-huh.
Why is that an exception? I hate this keyboard. Okay, so that's the label. I can't, the keyboard is flat and it's hard to type on. Okay, so that's going to be used now instead of our variable name when it actually creates the charts and so on and so forth. So next thing is values. Okay, now this is only used for categorical variables. And we'll see that in a second, because I'm going to go back and I'm going to put in gender as my next variable at some point. So now I'm going to go over here to missing. This gives you an opportunity to code in if you are missing values. So for instance, you're doing a survey. Normally in a survey, you're not going to be collecting only heights. You're going to be collecting gender, names, addresses, patient numbers, blood pressure, so on and so forth, a lot of variables, right? Now, perhaps you may be doing a survey. Maybe there's a question they refuse to answer on a survey. Maybe there's a question you forgot to ask in a survey, right? So you can, in this point, you can tell SPSS that if there is a missing value for that particular variable, for that height, for instance, you have the other data, gender, address, blood pressure, whatever else, but you don't have the height, you can tell it that, don't worry, just ignore the missing values. You can tell it to assign a specific value to the missing values. For instance, you could tell it that 99 means that that value, 99 means that that particular subject refused to give you that information. 98 might mean that you forgot to ask, and so on and so forth, right? So you could apply codes to these numbers to decide what that missing value means. So for our purposes, we're just going to say that we're going to ignore missing values. Okay, so when we calculate our means or standard deviations and so on and so forth. So the next one is going to be columns. Okay, and I don't remember what columns is for. Okay, but the next one is alignment. Okay, and alignment refers to whether the data is going to be centered in the column or left aligned in the column. If you click in there, it'll give you a chance to decide which one it is. I'm going to leave it with left, which is probably what the default was. Okay, and this is you can break the data up into different columns. And next is measure. I'm going to switch the bar over here a little bit so we can see that a little bit better. Move this over a little too. Okay, measure, and I'm going to click in there. And this is the point where you tell SPSS what kind of variable this is. And it gives us three choices. It gives us scalar, number scale, numerical variable, nominal variable, a name, or it gives us the ordinal, which is a nominal variable, but it has order, not specific number value, but it has order. Okay, in our case, this is numeric variable. It's a scalar variable. Why is that important? Because it may keep you from doing certain analysis. If you tell it it's nominal variable, it may not allow you to calculate an average, right? So somebody posted on Facebook, you know, if you are subscribed to Facebook pages that have anything to do with statistics, you always get like really bad statistics jokes, and you know, so when you misidentify a variable, for instance, let's say it's confusing. You try to apply numerical statistics to nominal data. Well, then you get something like the average American has one testicle and one breast, right? Doesn't make any sense. That's why it's important that we identify the type of variable that it is correctly for SPSS. For it to do it, for it to allow us to do the work we need to do, and also to make sure that we get the right answers. So I'm going to go back to our data area here, and I'm going to actually do the statistics that we just did in Excel. And notice I pasted it in here. You could just easily have typed these numbers in here. So I'm going to go up here too, and let me think. Where's a good place to start an analysis? Let's try analyze. I'm going to click on analyze. And I'm going to go down here, past reports. I'm going to go to descriptive statistics. The statistics that we're working with are called descriptive statistics, right? Mean, median, so on and so forth. Okay, so I'm going to go over here to frequencies. Well, frequencies is a count, right? Like number of people that meet this criteria, number of left-handers, number of males, number of females. Frequencies is more applicable to, usually to categorical data than nominal data. So for the moment, I'm going to go past that, okay? And I'm going to go to Analyze, Descriptive Statistics, and the next one here is Descriptive. So I'm going to click down on that, okay? And a box comes up. Well, normally I would have 2 variables, 10 variables, 50 variables that I'd be working with at the same time, not just height. So because I only have height in here, all I see in this left box, which gives me my available variables that I can work with, all I see here is a height, right? So it's pretty easy to say I got to choose that one and move it over to the variables I want to work with in here. Okay, if there were 20 variables and I only wanted to work with height, I just click on height, just move height over. Okay, and then I'm going to go in here and see options. Well, look, now it asks me, well, what descriptive statistics do you want? Well, it's got mean checked off. It's already got standard deviation checked. Let's check off variance. Let's check off range. Okay, and I think that's pretty good. Minimum, maximum. Okay, so some of the things that we were looking at. So I'm going to click continue, and I'm going to say okay. Okay, now SPSS is going to grind and whir. The gears are going to turn, and pretty quickly, a new window is going to open up. This is a different window. It's not the same window. I don't know why that came up. Okay, this is a different window. Notice it's separate from the data window, data and variable window. This output window this is where all your results are going to wind up being. And if you look at this, here's our descriptive statistics. The count and height of boys count was 10. The range was 22, was 39 and 61. Here's the mean, the standard deviation, the variance, whoops, I'm too far there. Oh, I clicked on the other window. That's what I did there. Okay, and sure that I don't do. I can get some more of this window here. And the variance is down there. Okay, so there's a couple of things missing there also. So maybe there's some more I can do here. I'm going to click on Analyze, Descriptive Statistics, and I'm going to go over here. I'm going to go a little bit further down. I'm going to go to Explore. Okay, let's just do a few more things. Well, first of all, this dependence list, that's the variable I want to work with. I'm going to move the value into here. I'm not going to worry about this other stuff for right now. I'm going to click on Statistics. And Statistics, it says, okay, descriptives. Doesn't give me a choice for descriptives. That's because it's going to do just about every descriptive statistics that you would ever want to see. I'm going to click Continue. And I go over here to Plots, okay, which is graphs, plots. And it's already, let's see if I can level together. You know, it doesn't have histogram checked off. So I'm going to check off histogram. And I'm going to say Continue. And down at the bottom here, it says display, when you do the output, display the statistics, the plots, or both. I'm going to leave it on both. I'm going to click OK. And SPSS is going to do the statistics, and it's going to present them to me right below where it adds on to that list of statistics that I did before. And the first thing I get, I'm turning this the wrong way. Look at all these statistics. The mean, the 95% confidence interval, don't worry about that. Median, standard deviation, minimum range, interquartile range, and a whole bunch of other statistics as well. Here is a histogram for the heights of the boys. Notice what he used for the title of the chart. Use heights of the boys, right? Because instead of height, if I hadn't put that into the label, it would have just used HT or height or whatever. So it wouldn't have been as descriptive. Okay, it comes up with something called a stem and leaf plot. I wouldn't worry about that. No, people don't use that anymore. But look at this. It also creates something called a box plot. I think we brought that up first lecture. We brought up box plot. But what does that mean here? Well, notice that this leaf down here represents the shortest boy, which is 39 inches. The leaf at the top represents 61 inches, the tallest. And this box represents the middle 50%. Okay, and so the 25th percentile is about 48. The 75th percentile is about 53. So our interquartile range is between those two. I think it comes out to be 6 actually. And what do you think this bar in this dark bar in the middle is? What do you think that is? That's not the average, that's the median value. That's our 50th percentile. What is it? What do you notice about where it is in relation to the 25th and the 75th? It should be in the middle, right? Right? It's not in the middle. So what does that suggest? That suggests that this distribution is skewed so that there's a difference in the distribution above the median, below the median, above and below the median. It's not like a nice bell curve. It's stretched out on one side or the other. I'm not going to worry about which side. Notice it created the histogram because I told it to, but it always, when you use Explore, creates a box plot. Okay. So that's pretty cool, right? Here's statistics. We didn't have to go through all that torture in Excel. It did all this for us that quickly. Okay, so now what I'm going to do, I'm going to go back to this data, right, to my data view. Here's my data view. I think, yeah, there's my data view. And I'm going to go and I'm going to create a new variable. And that new variable is going to be gender. Let me pick the right keyboard and try to, see if there's a way to, yeah, there is. So I'm going to put in here, I'm going to call this gender. And I'm going to go across here, and I'm going to leave it numeric for a second, just because I want to do something interesting here. So I'm going to make the width as 6 and 2. I don't care about that. I'm going to change this to 0, no decimal places. the reason why I'm doing that is because I'm going to use a number to represent the gender, right? Okay, there's a reason for me doing that. As we get to it, I'll tell you what that reason is. Decimal place is 0. Label. A label, I'm going to put sex of student, just to be different from the oh, I typed it into the wrong keyboard again. Okay. And now, when I get the values, remember I said when I said if we have a numerical variable, we don't use that values. The value is the number. Well, when we talk about a categorical or a nominal variable, the value I put in very frequently isn't the actual value that we've recorded. So what we've recorded is males and females, right? So I'm going to, but the value I'm going to translate that into is, I'm going to say that 1 represents, the number 1 is going to represent males. Okay, and then I got to click add, and the number 2 is going to represent, did I put a 2 in there? 2 is going to represent females. And I'm going to click add. So, and then I'm going to say OK. So from now on, in this variable, when SPSS sees number 1, it's going to know that it's male. Sees number 2, it's going to know it's a female. So I'm going to go across here and write measure. I'm going to click in measure. Which one should I choose now? It's a nominal variable, right? Even though it's a number, it's a nominal variable. 1 represents male, 2 represents female. Still, it's a number being used as a name. So I'm going to choose nominal. So now I'm going to go back to my data view. And now I don't actually have the data in here. So I'm going to put the data in here. So the first, is this sorted? Yeah, it is. No, it isn't sorted. So I'm going to make the first 5 males. I'm going to take second 5 and make them females. Okay? Oops. I messed that up. Okay, so I'm looking at my data, and geez, I don't remember what I put in here. What, did I make 1 females and 2 males, or the other way around? Well, if I go up here to view, see this little tab up here at the top called view? If I click down on that, there's a choice here called value labels. That's called a toggle. When you click it, it changes to the other value. And click it again, changes back to the original value. Toggles like a toggle back and forth. So I'm going to click that. I'm going to click that. And now you actually see the names, male and female. If I go back up there to view and I say hit it again, it goes back to 1s and 2s. So SPSS understands that 1 and 2 represent males and females. Now I'm going to leave it toggled on. So there's actually really only. So why would I want to use 1s and 2s here? Right? Well, let's say that you're collecting data. You have someone like me that's spazzing out on the keyboard over here because it's cheap keyboard, it's crummy keyboard, and it's not my fault. Let's say that I'm typing very badly, and one time I typed males, M-A-I-L, right? Uh-oh, okay. Computer gonna understand that? No, it's not gonna know that's the same thing as M-A-L-E. If I type a lowercase M-A-L-E, is that the same thing as an uppercase M-A? No, it's computer. It's got to be exactly the same way, right? So by using 1s and 2s, we avoid that confusion or that kind of error. So it's good to do that. In the old days, when memory was, if you had very large databases and memory was very limited, instead of typing the words, instead of typing words like elevated blood sugar, instead of typing that in as a name or a category, you just put a category 1. or lower blood sugar, 2 instead of that. And then put into the value labels what that represents. So you'd save a lot of memory space. Nowadays, memory is like, junk. Doesn't matter, right? Everybody's got way more memory than you ever need, right? So, and hard disk drive space and so on, at least in our business, right? If you're a videographer or a photographer, so memory is still an issue. But for us, memory, because we're dealing with this kind of data, memory is no longer an issue, but it was at one time, believe it or not. So anyway, so now I have 2 variables that I'm dealing with. I can identify what the gender of a person is. This is still subject 1, this is still subject 2, and so on and so forth. Let's do our analysis again. I'm going to go here to analyze, analyze descriptive statistics, and I'm going to go to descriptives, and I'm going to say it's already moved over. I can't put gender in there, sex of student in there, or gender. See, gender's in parentheses. Can't put that in there because this is descriptive statistics for numerical variables. So all I can do is run this again, and I get the same result again. Nothing's changed, right? So now let me see what happens if I go further down. Analyze, descriptive statistics, instead of descriptives, go to explore. And you remember that second box that I had down here, factor list. Okay, now I can take my nominal variable or categorical variable categories. I can move that into my factor list. What's going to happen here? What's going to happen here is that, what does factor mean? Factor means break up into its component parts, right? So for instance, if you take the number 6, you can factor it into 18 times 2. You can factor it in 6 times 6. You can factor it in 3 times 2 times 2. And so on and so forth. You break it up, right? So when I put gender into the factor box here, what I'm telling SPSS to do is to break the data up into males and females. So everything is still checked here. If I go into statistics, it's still checked, do my descriptives. If I go to plots, it's still checked, do a histogram. And now when I say, do both, and I say click OK, what's going to happen when I click OK? That output window is going to come up again. And the new data, the new output is going to be added to the last. It's not going to erase or overwrite the old one. It's going to be added to the last one. And let's see what that looks like. Okay, here we go. Well, look now, case summary process says males is 5 males, 5 females. No missing values. And then down here, descriptives, we have a separate calculation for the mean height of the males and the mean height of the females. Pretty close, actually, right? And separate calculation standard deviation, separate calculation of range, separate calculation minimum maximum value, separate calculation of interquartile range, and so on and so forth. And then I get separate histograms for males and females, right? Obviously, this data, there's such a small data set that these really don't mean much. And then finally, at the end, for my box plots, I get 2 side-by-side box plots. And what do I see? I kind of could see it in histogram anyway. I see that the data for females is much more, so the 2 medians are very close, right? Not much different, but there's much more variability in the female heights than the male heights. It's called side-by-side box plots. Very useful because at a glance, I can see how this information is distributed, males versus females, right? Pretty cool. Okay, so what do I do with this now? Well, what I can do with it now is I am going to go here, and I'm hoping that I can find Microsoft Word. Where is it? Microsoft Word. I don't see it. You see it?
Above Microsoft.
I see PowerPoint. That's
Right.
it.
No.
Oh, there it is. Thank you very much. Okay. So here I am. I'm putting together my capstone. I'm a little bit ahead of the game, right? Capstone. Putting together a report for epidemiology. Okay, what is this? Something's unavailable. I don't care what it is. I just hope it starts. I think it's okay. Let me make this a little narrower. Okay, so here I am putting together my report. Go off the screen. Okay, I'm typing away, putting all sorts of interesting stuff. I got some really nice references and footnotes and so on and so forth. And now I want to put in my table. So I can go back here. Wrong one. I can go back here and I can switch the window to the output window. Here's the output window. And I can go scroll back to, oops, sorry guys. Let me turn that thing off. I'm beeping anyway. Okay. So I can go back here to my descriptive statistics, this big table I did back here. I click on it. Notice when I clicked on it, you see our box kind of draw around it. I'm going to right click on that and say copy. And I'm going to go over to my Word document and I am going to click in there and I'm going to say paste, right? Now I can either, there's a bunch of paste options that I have. Okay, I just dropped it in. Okay, and there, it's pasted into my document. I think if I go into the right spot, yeah, if I go into paste here, paste options, paste special, if I go into paste special, it will allow me to paste it as formatted text, unformatted text, so it gives me a little bit of flexibility. If you're lucky, the way it's supposed to work, if it's properly installed, and a lot of times you'll install it properly and this won't quite work right. One of the choices here will be either JPEG or TIFF or something, some form of picture. So you can, right now it's pasted in as text. So I could actually go in here and I could edit individual words. I can make them red. I could highlight them. I can change them. If I don't like the numbers, I can change all my research, right? So that's not ethical, but you know, if you need to do it, you need to do it. So at any rate, I can edit this. The only problem with that is that you know that working with multiple columns like this in Word, trying to get this to fit in, not spill off the page, can be a little bit of a headache, right? So sometimes you can edit your charts and tables in SPSS, in the output window of SPSS. So for instance, I'm going to go to this last box spot. I went the wrong direction. The max scrolls the opposite direction of PCs. You can double click this and it opens a window, a set of controls where, there it goes. Oh, kind of disappeared on me again. Where now I can go in here and I can edit the text and change the labels and so on and so forth. And then just close this and it'll update the output window of SPSS. I can edit that in SPSS. In other words, same way I could edit a word. The only thing is that now if I say, I'm going to say copy, and then I'm going to go to my report. I'm going to get down here at the end. I'm going to hit enter a few times just to make things neat. And I'm going to go in here, left click, so I can paste. What happened here? I didn't copy it. Might not have had it copy. I'm going to go back. It's got to be selected. I'm going to go back here and I can say paste, right? And let me see if I got the options here. If I go to paste, paste option, paste special. See, now in this case, I can paste this chart in as a JPEG or a PNG file, a graphics file. I'm going to choose JPEG for the hell of it. And then I can drop it in here. What does that do for you? That's much easier to just simply resize if you need to and move around the document if you need to. So some of you, when you install SPSS on your computer and you have Word on your computer, this will work great for you. Some of you will have a problem with it where it won't give you, like in the first time I tried it with table, it won't give me the option to paste it as a picture, right? You can get, there's a lot of workarounds for that. You can use like a screen capture or a, in the Mac, there's a program called Grab that lets you grab a portion of the screen and save it as a JPEG and so on and so forth. So you can use that instead. But now we have a way of doing all sorts of great graphics and create tables and do statistical analyses using SPSS, and then taking our results and putting them into a document that we can give to someone else, a PowerPoint, a Word document, and so on and so forth. Okay, so a poster, if you're doing a poster presentation, we'll talk about what those are later on in the semester. As you go through your career in public health, you'll wind up going to conferences and stuff like that, or nutrition. You wind up going to conferences, and they do these presentations. People present their research at conferences very frequently. They will have, if they have really interesting stuff they're doing, they may be, or they're very prominent, they may be presenting their research by giving a PowerPoint presentation, standing at a lectern, having a room full of people. But they might only be able to do that for 10 or 20 people, but there's hundreds of people doing research that's important. So they have poster presentations. They have halls where they take these large, remember you used to do science projects on OTAG, right? Those days. Well, this is kind of a version of that. They get it professionally printed, and it's a large, maybe 3 foot, 4 foot, or 5 foot by 4 foot poster board with professionally printed graphics and text and so on and so forth. And you present your graph, what your objectives are, what your statistics are, your graphics, your conclusions, your research. You post it on these posters, and they'll have rooms where there'll be 100 or 200 of these posters mounted on displays where the researcher will be standing next to it. So at the conference, you can walk up and down these rows of poster presentation. And when you see something that's relevant to you, you can read the posters, see what they're doing, what the results were, and they often are available to you right there. You can talk to them about that research. So SPSS, you might create the graphics, the statistics that you're going to include in your poster presentation, or if you become a big shot in your oral presentation, right? Posters are better because you don't have to stare at all those people out in the audience. Much less sweat involved with posters. Okay, much more intimate and a friendly environment. Okay, so at any rate, so that's important because that gives us now an opportunity to use this usefully. Well, when I say use this usefully, what I mean, assignment 1, how many of you guys have tried assignment 1? Did I post assignment 1? For this class? Okay, I have another class I'm doing with this concurrently, and when I saw no hands go up and a couple of puzzled faces looking at me, I freaked out that I posted it in the wrong class. Okay, so I did post it, right? So now I'm going to take back the presenter status, and I am going to go look at assignment 1. Okay, so let me see here. Where am I? There I am. Okay, make presenter. And things should magically change back to my computer. Okay, now I haven't been able to see the chat box. So there could be a lot of people freaking out there. No, it's not a thing in the chat box there. Okay, oh, actually it might have been in the other chat box, and now I can't see it anymore. Okay, so let's take a look at what the assignments area looks like on Blackboard. I'm going to move this out of the way. Okay, here's assignments. Okay, first assignment, city program certificate. I'm going to click on that. It's going to open up and it's going to say, oh, let's see. It's going to say, when's it due? It says due December 14th. That's like the week before the absolute dead end of the semester. And I just put that date in there as a placeholder. You should really do it early so you don't have to deal with it at the end of the semester, right? That's the Human Subject Resources, HSR course. And all you have to do there is browse my computer, locate the PDF file, which was you got from your course, add it to there, and then upload it. If you uploaded the wrong thing or something like that, or you have to redo it, I fixed it so that I know when one person had to re-upload something. I fixed it so that there's unlimited uploads. So if you mess up the first time, or you think you put the wrong document, you could try it again, just upload it, and it'll add it to whatever you uploaded. Okay, so that's all you have to do with that is upload that document. I'm going to go back, and then the other thing I have here is assignment 0. Let's introduce ourselves. Well, what is that all about? It's basically, it's asking you to go to the discussions board. And to go to the discussions board, and I already have, I've noticed a couple of people. If you have questions that you have on the city program, click them there. I see there's people that have already started adding a couple of questions. I think I looked at one of them, but I don't think I looked at the other one yet. I think I noticed one. I replied to one maybe. Okay, and this other part here, let's introduce ourselves. This is basically an assignment. What I'm asking you to do is to go there and post a brief introduction describing why you're here, why you're taking this course, why you're being punished, and whatever you need to put in there that you feel comfortable with. You don't have to put any personal information. If you want, you could just make stuff up. I don't care. Don't make up your name, because you can post anonymously. But for this thing, I want you to use your real name, because it's kind of an assignment. Why is this silly thing an assignment? Because I want to make sure that everybody in the class knows how to get to the discussions forum, knows how to add to a thread, and knows how to respond to someone else's thread, right? And the reason for that is because since you guys are so diligent that you came in here today when you could have stayed home and with a bathrobe on and a nice iced tea and sat at home and listened to this disjointed session that we've had. I don't know what the experience on this switching back and forth on the computer was for the people at home, but hopefully it wasn't too bad, right? We got pretty much what we did. Okay, so you've been diligent enough to come in here. That may not always be the case. You may not be able to make it. Maybe other reasons, and so on and so forth. Professor Navder, nutrition, she really would prefer you come in. In fact, in previous semesters, she told me that it was a requirement for the nutrition students. I don't care what those other students do. My nutrition students got to show up. That's what she told me. She didn't really put it that way. She's much nicer than that. Okay. But this semester she said no. That it's up to you guys if you want to show up in class or not. I think usually she says that because there has been an issue with register for the description that different people registered for the course in. Sometimes you'll read and it'll appear to be a strictly online course, and sometimes it'll be a brick and mortar course. And because of the confusion, some people will register thinking they're taking one kind of course and wind up in another. So we give you the flexibility to do it either way if you want, right? So you don't have to show up here. You are welcome to. Certainly, it's a lot nicer for me when I got somebody to talk to. If you notice, on the second half of the first lecture, I forgot to turn recording back on. So I had to substitute, like for that exercise, I had to substitute an old recording that I did plain, just like talking to the computer, no people and stuff like that. And you can tell I'm droning there. I don't even like listening to it. At least when I have a room full of people, I'm animated, I'm looking around, I'm talking, I'm changing my tonation, I'm raising and lowering my voice. So it's much easier to listen to than when I just stare at a screen and talk to the screen. So I like when people show up, but you don't have to, right? I'm not taking attendance except for right kind of now, and this assignment because I have to put down whether you are attending the course or not for the register. They use it for scholarships, for visas, student visas, and stuff like that. They need to know that you're attending. If you're getting some sort of benefits out of attending. So I need to put that in this week, unfortunately, because we're so late. We get such a late start. Okay, so that's the deal there. And you'll notice I also have down here, I put in a thread for general course questions. I got one already. SPSS installation issues and so on and so forth. I'm not going to click, I'm just going to click into let's introduce ourselves because I'm presuming that you didn't put anything, as I mentioned over and over again in this thing, that don't put anything that's more personal than you want to. So you can post anonymously if you want, except in there, because I need to know, and it helps if you don't post anonymously, because at the end of the semester, since many students are taking this online, the only way you get to gauge a participation score for them, which is part of the grade, is by looking back at the discussions board, because they're not in here to talk with us and stuff. Right, so here you go. So a lot of people have done that. You'll actually see that there, for instance, there's two posts here. That's because someone responded to that. So I would like you to post yourselves, like create a thread. Now you go up here, create a thread, like so. Okay, Tony. Oops. Yeah, now I got down to this keyboard. I can't type on this keyboard. This is a test. Okay, but actually you would write something useful in there. You can actually put in an image if you want. Insert image, and it'll let you browse and so on and so forth. Then I'll hit submit. And now I will be added to that list of people who have done these. It goes, and the most recent ones are at the top. So if you saw that you wanted to add a comment, you would click this, and now you would have the opportunity to click onto that and say, this is a reply. And I know for the most part, you guys have no problem with this, but I just want to make sure that the few of you that might stumble with, might not view something like this before, have an opportunity to do it as well. So that's the second assignment. The third, and actually the first actual assignment, the number one assignment number one, which I actually called assignment number one. Let's take a look at it. Okay, let's see. Now, there's stuff here that you can't see hidden from students. Did I post assignment one? Here it is. Assignment one, there it is. I didn't post it. Okay, I didn't post it on purpose because we only started the other day and we never got to work with SPSS. And it does involve SPSS. I'm going to click into it, but before I actually make it available, I am going to check it. So I'll make it available to you guys tonight. Okay, but I'm going to click into it now so you can see what it is. Okay, and the due dates, because very frequently I will kind of like change the due date on the fly from what's in the syllabus to what makes sense, because I like to do it to match what we've actually covered in class, rather than ask you to do something we haven't covered in class. So you'll see the due date in the name of the assignment. That's the real due date. And again, that due date is a loose due date because all I'm asking you to do is that by that date to complete at least one attempt on the assignment. Don't have to get 100%, could get 30%, could get 40%, could get 90%. You have the opportunity then, anytime, right then and there before it's due, or even after it's due. As long as you made that first attempt, you can go back anytime in the semester, even December 14th, and redo that homework. You have unlimited tries at redoing that homework. Your grade is the highest grade, not the last grade, but the highest grade. The reason why I do that is because, let's say the exam is coming up and you say, oh, the first 3 or 4 homeworks are going to be relevant to this exam. I want to redo the homework again because I don't remember. It's been a while since I've done it. So you can have the opportunity to go back and try that assignment again, right? Without being penalized, because let's say you'd done the first time, got 100, and you did it the second time and got an 80, you're not going to be penalized because it's only going to take the higher score, right? So you don't have to worry about your score being the last score. It's going to be the highest one, no matter how many times you try the homework. Okay, and all the other scores are ignored. Okay, and so this involves, you notice that there's several data files here: student test scores, student test scores Excel file, student test scores as a SPSS file, and another file called NC Birth 800 mod SPSS file .sav. It's an SAV. .sav means it's an SPSS file. Okay, so if I go into the assignment, okay, it's going to ask you that it can be saved and resumed later, so on and so forth. You have multiple attempts. I click begin, and now it's got a series of multiple choice questions and so on and so forth. And then you're going to get to eventually a question here. Using the data provided in student test scores.xlsx Excel file, use Excel to calculate the mean, median, mode, variance, standard deviation, minimum, maximum, 25th, 70th percentile, interquartile range. Well, you know how to do that now, right? We did that. You know how to do that. But the file will give you the actual numbers, and the file's in that other area there. Okay. So when you're done, what does it ask you to do? Upload your Excel file here. In other words, save your Excel file, click on Browse My Computer, upload the file to there. Next question. Repeat the calculation of previous problems using SPSS or other statistical software. For the most part, you guys are going to be using SPSS. If you're really an adventurous person, you can use anything else you want. Okay, I'm presuming if you wind up using R or SAS, it means you have probably as much experience or more than I have using those programs. So you're welcome to use them if you know how to use them. Copy and paste the resulting tables or graphs into a Word document. In other words, browse my computer and upload the document. I don't want you giving me like an Excel, like in the previous problem, I wanted an Excel file. Just send me an Excel file. Now I want you to take the relevant chart or table, copy and paste it into a Word document, and upload the Word document. Why is that? Well, a couple of reasons. The one is that not all versions of SPSS will open output from other versions of SPSS, and it can be a little sloppy opening them and closing them. And you can see that output page has all sorts of other detritus on it by the time you get done. So I want to just see what we're asking for to answer the question, number one. And number two, the ulterior motive, the real reason, is because you're never going to give somebody an SPSS output file. You're going to give them a document which has the table that you want them to see, like a Word document, for instance, or a PowerPoint document. So why don't you copy it to a Word document and then upload the Word document instead. Okay, and then the last part here is use the NC birth file to compare the mean, median, and standard deviation for the weights of infants in grams born to women who were married versus women who were unmarried. Okay, what does that tell you? That tells you we got a file there with a lot of variables. It has 800 subjects. It has maybe 15 or 20 variables. Among those variables is the birth weight of the infants. Each subject is a birth, right? Has the gender of the infant, has the birth weight of the infant, has the amount of weight that the mother gained, has the weeks of gestation, has so on and so forth, has those. We're only interested in the weights of the infants in grams born to women who were married versus women who were unmarried. So there's a variable there, married, marital status, right? So that variable is going to be your factor. So you're going to move in weight of the infant at birth in grams. There's also one in ounces. Weight of the infant at birth in grams, and then into the factors, the marital status of the woman who gave birth. And as it happens, there's you could have many. It could be married, unmarried, single, separated, widowed. Could be a lot of different married. This one's just married, unmarried. Just one and twos, just like our other data. Make things simple. And it's asking you to give us all of these statistics, right? So you're going to use Explore, descriptors Explore. Why are you going to use descriptors Explore? Because you're going to use descriptors Explore because you need to separate this into married and unmarried. And just descriptors doesn't do that for you. And what else? Also, Explore is going to give you side-by-side box plots, which is also what we're going to ask you to paste into that document. Okay, so I know a lot of you are going to copy and paste the entire output of that table into a Word document to send that to me because you're so paranoid that you're going to leave something out you should be putting in there, right? I would prefer to you that you leave something out rather than just copy and paste it. Just make a judgment. Oh, I think he wants that and that table and that graph. And that's what I'm going to paste in there. Right? Maybe a couple of words in between saying what they are. Right? So, do it that way. I'm not going to make a big deal about it, but it just makes sense. Just look at it as a thing, practice what you're going to be doing with it in the future. So that's that homework assignment, right? Not that hard, right? The other parts are like identifying variable types and so on and so forth. So you'll get a look at this. I'm going to look it over just to make sure it's not going to cause a problem. So that's why I'm not making it available right now. Okay, so I think this is a great time to take a break because the session's almost over anyway, but it's a great time to take a break because I want to mention a couple of other things about SPSS when we come back. And my voice is going, so I need to drink some. Okay, let's take a 10 minute break, and I'll get you guys out of here a little early today. Okay. So you guys online, I hope that wasn't too much of a horror for you guys. Switching back and forth between computers. Let me get my tea. I feel the same way. Yes, Vanessa, that's exactly right. And you can't see that assignment yet. I'm going to just check it's available. I just got to turn it on so you can see it. But I don't want to do that until I get a chance to check through it. In fact, I may even break it up into a part A and a part B. Where part A is the multiple choice, excuse me, and part B is the Excel and the SPSS portion, just to make it a little easier to. In case for those guys that don't have SPSS yet or having issues installing SPSS, to be able to do the first half and not have to worry about the second half.
This conference will now be recorded.
Okay, guys, I just wanted to mention a couple of things about SPSS. I'm not going to open it again because it's going to cost. We're going to spend 10 minutes going back and forth here again. Hopefully by next Monday. Wait, by the way, we have another. We're going to miss another Monday, right? Coming up, is it this coming Monday or the following Monday? Right? Yeah. So next week we'll be meeting on Monday, though. So by the time we meet next Monday, I'm sure this will all be worked out. So, a couple of details about using SPSS, and that is, you notice that we worked with two separate windows, literally two windows, one behind the other. You can go and switch between them just by clicking on them if they're available in the desktop, or you can go up to the window drop-down menu on SPSS to window and go down there and choose data window, output window. There's a third type of window also, and that's called a syntax window. SPSS has buried in it a programming language. We can actually program it to input a data file, to process it a certain way, follow a number of instructions, output the graphics or the other information that you need, or tables and calculations and so on and so forth. You can actually type in these instructions. You can store them. You can do it one time, you could store them as a program. Some of these some of the language, the words in that language, some of the functionality, especially we're not going to wind up with any kind of issue with this. Everything we need is going to be available in those drop-down windows. Some of the specific analyses are sometimes easier to find unusual processes or unusual conditions within that syntax language than in the drop-down menus. Drop-down menus are kind of a summary of everything that SPSS can do. Not exhaustive, obviously, because there are so many things that you can use it for, right? So if you use SPSS professionally, sometimes you'll learn use the syntax window, sometimes you'll learn to just use the data to output windows. Now, you may have noticed also that every time I ran an analysis, there were some words, there was a series of text before the tables and the graphs that were produced. That is the syntax that's equivalent to what you did with the drop-down menu. So if you want to have a feel for what the syntax language looks like, time you say analyze descriptive statistics and you tell it, okay, go and do the analysis. When the output window comes up at the top before your results is going to be the equivalent of what you've chosen and asked it to do, the file you opened, the statistics you did, the output you asked for, and so on and so forth, in SPSS syntax. So it's a good way to get a first look at what the SPSS syntax language looks like. Not only that, I've seen some people use it as a method for documenting their work in the output window. In other words, if you're ever wondering what option did I choose here when I did descriptives explore, and so what options did I choose there? You'll see it in the syntax window. You'll see a description of what options you selected were in the syntax window. Okay, so and not in syntax, in that syntax block in the output window. But you can actually open a separate window called syntax window where you can actually write programs and so on and so forth. I gave you the data for the assignment as an Excel file and the same data as a SAV file, as an SPSS file. Okay, SAV files are SPSS data files. SPV files are SPSS output files. And I don't remember what the postscript is for the syntax. We'll give it a try next time. So they're separate. I gave you SAV file, Excel file with the same data. And I gave you an SAV file for the birth data, the North Carolina birth data. Okay, so that you didn't have to worry about transferring files and importing files and so on and so forth. Next week, I'll show you how you can take files from other programs, or other databases. Like, for instance, take a file from Excel and import it into SPSS. Okay, so we'll take a look at that also. The final word on SPSS is that data window, that output window. And if you happen to be working with the syntax window, for us, we're probably not going to be working with that. You have to save them separately, right? So in other words, if you say save as output window, right, and it saves as an SPV window, SPV file. If you don't save the data window, any changes you've made to the data is lost. You got to have the data window up front, say save as, and save it to wherever you want, or save to update it, right? And then when you want to save the output window, you have to bring that to the front and say save as if you want to save the output window. One of the other things you can do with the output window is you can say save as or export. You know, instead of saving it as a .spv or a SPSS data window, you can save it as an RTF file, a .rtf file. .rtf file is called a rich text file. It's basically, at this stage, it's basically the equivalent of a Microsoft Word file. Okay, it's not exactly the same. It doesn't have all the formatting in Microsoft Word, but it will store your data, your images, your charts, your graphs will all be output as a window, which is basically a Word file. So if you have trouble pasting, like just choosing paste special and choosing I want to paste a picture, that may be another route you can take. There's a lot of workarounds. You can use a grab kind of thing, do a screen grab. You could save the output window as an RTF file, and then it'll already be pasted into Word, I hope. But if you have other problems, you can just post them into the discussions board, and I'll start checking them tonight and seeing if you guys are having issues with that. And if a couple of people mention it that have issues with it, with the current downloads and versions, I'll post another thread where we can discuss this. Another reason why the discussions forum is so useful in this class. Okay, if you have a problem cutting and pasting, or there's an issue with the program, and half the class has that same issue, it's easier for me to answer one person, and rather than answer 35 emails from 35 different people, right? So it's important that you put it in there as well. The other good thing about that is that you'll also, if you check the discussions forum every once in a while, you'll notice that, gee, somebody asked me about that, and there's my answer. So you may not have thought to ask me, or you may have forgotten about it or something like that. So that'll mean that since you can see my answer, which you wouldn't see if I just said private email, since you can see my answer in the discussions forum, or you can see other students' answers. You can also take part. I mean, that's part of what you do with the forum is that everybody takes part. And if you get to it first and you know the answer, go ahead and do it. So you'll see that question answered. So rather than being left out in the cold and not getting that information, which everybody else is getting, you have an opportunity now to keep up with that kind of information as well. So you want to save each window separately. Okay, so let's see if I have time for one more thing here. And we're not gonna be tested on this, but as we progress through the semester, you are gonna hear, sometimes gonna hear about things where you might have a data set that's provided to you, or a data set that you collect, and you might hear occasionally the term unstandardized data and standardized data, right? So what the hell does that mean, unstandardized data? Well, unstandardized data, it's pretty easy to understand. It means nobody's monkeyed with the data. It's just the raw numbers. Nobody's adjusted them, changed them, corrected them, and so on and so forth. It's just the raw data itself, the actual numbers. But standardized data, what does that mean? Okay, and why is it important? Okay, so I'm gonna give you an idea why that might be important. Okay, let's see if I got it here. That goes by. A lot of the stuff you can't see there. Oh, not there. Let's try number 2. Okay, there is a lecture there that you should play as well, a video for a lecture that you should play as well. Goes over, one of the important things goes over is study design. We didn't get to it here, but next week I'll try and at least review it. But in the meantime, you can take a quick look at it. Okay. Okay, let's see if we can open it up. Okay, here's a file. Cardiovascular disease. This actual numbers from the city keeps very exhaustive data on mortality, and you can download this data. There's a morbidity and mortality and morbidity reports that they publish, I think, weekly or something like that. And then there's a summary, year-end summary. I'll show you a picture of it next time. This data actually came from an old version of it. You'll notice the population is a bit smaller. This only includes people from 25 to 85 to 25 years old and up. And for instance, right here is the population of females that are in these various age ranges, and the population of males that are in these various age ranges, and the number of deaths due to cardiovascular disease. Now, if you went to this report, you would find number of deaths due to suicide, number of deaths due to liver failure, number of deaths due, and so on and so forth. You find all sorts of other causes of death. It's interesting because you'll see in different age ranges, like 15 to 24, especially for males, what's the leading cause of death? Accidents, right? Because they're idiots. And I know I was an idiot at that age, right? So they do risky behavior. Risky behaviors contribute to the leading cause of death. As you get older, cancer and cardiovascular disease move into the forefront for causes of death. So let's take a quick look at this. One of the things I can see very easily is that the number of deaths amongst females was the sum. Oh, I'm sorry, the total's already there. There's the total number of deaths among females during that year due to cardiovascular disease. There's the population of females that died from that these 12,000 people were part of. So I'm going to click in here. I'm going to calculate the crude mortality rate from cardiovascular disease for females. And that's going to be equal to the number of deaths from cardiovascular disease divided by the total number of people in that population, the total number of females in that age range. And it's 0.0004. It's 4 out of 1,000, 44 out of 10,000. There's a better way to describe this. I'm going to click in there. Another way to describe 0.4%, which is what this is. Another way to describe this is if you look at the top here, I'm going to multiply this whole thing by 100,000. I'm going to put parentheses around here, and I'm going to multiply it by 100,000. Okay, and it becomes 442. Well, what I've just done is instead of showing it as a percentage, what is a percentage? It's the number out of 100, right? That's a percentage, right? So instead of showing it as a percentage or a decimal or a proportion, it was a proportion. Instead of showing it as a percentage, which would have been move the decimal place over the 2 O's, and then it would be 0.04 or whatever it came, 0.4 or whatever it was. That's a percentage or per 100, right? Instead of showing it that way, I multiply by 100,000 instead of 100. And now I have the mortality rate per 100,000 women in New York City. That's simple, right? Take the proportion multiplied by 100,000. I'm going to do the same thing for males. That's going to be equal to that number of males divided by that population times result of that times 100,000. And everybody knows that males are more susceptible to dying from cardiovascular disease than females are. Uh-oh, what happened there? Didn't come out right. Those are actual numbers, by the way, right? Didn't work, right? What's the problem? Anybody want to guess on what the problem is here? Why did this happen? Let's take a look. How many females in this population? Population's rough, not that different. How many females are over 85 in this population? 87,000. How many males are over 85? 34,000. Why is that? They don't make it to 85. They die before 85, right? Not good news for me, right? So what does that mean? That means that there's a lot, the female population tends to live longer than the male population. So there's a lot more women that are in those older ranges of age. Well, we want to know something. Let's look at each age group and look at what the rate of mortality is from cardiovascular disease in each age group. 146 divided by this, right? And I'm going to change it per 100. I'm just going to leave it as a proportion. And it's 0.001. Okay, now I'm going to copy that down. I'm not going to go down to the bottom there. Whoops. Okay, it's practically negligible, 25 to 44. But what happens? 7% of the women over 85 years old each year dying from cardiovascular disease. Right? That's an enormous rate, the mortality rate when you get older. Look at the impact of getting older. Once you start to get out of that 65, once you get above 65, right? It really climbs quickly. Right, so since the population of females is older and skewed towards older compared to the males, if the populations are different, we're not comparing to apples anymore. What about males? There's not that many males left here. Equals this divided by the population in that age group. This is called the age-specific mortality rate. See, that's not that different. Let's see what happens as they get older. Now look, 7.6, 7.2. It's not different. What's different? The difference is the populations are different. We're looking at cardiovascular disease in a younger population when we look at males than we are when we're looking at females. How are we going to fix this? Because now we think that females die more frequently out of because cardiovascular disease, where really their rates may be the same or less than males if you compare them to the same age groups, right? And in fact, if you look at the individual age groups, you see they're really all the same. So how can we adjust this? How can I adjust this data? Problem here is that in this case, the confounding factor is the distribution of ages for males and females. In other studies, it might be smokers versus non-smokers, right? In other words, you'd have to control or adjust the data for people who are smokers versus non-smokers if you compare disease rates for something that might be related. So you have to adjust the data. So let's take a look at how we might adjust the data. Well, first of all, instead of applying these rates, the rate at which females die in each age group and the rate at which males die in each age group, to two different populations, population of males, population of females, let's compare them to the same population. If I took the same rates and compared them to a single population, I would take out that confounder of the distribution of female ages. So if I go down here and I say to myself, what am I going to use for the populations here? I could say just 1 million in each age group. I could do that, right? And then apply the age-specific rates for females, age-specific rates for males, and see if we see a difference. I could do that, but that's kind of a little messy because I'm really changing the distribution age. How about if I just add together the female population and the male population so that I get in each cell here, I get the total males and females for that age group. And then I apply the age-specific death rate for females and see how many females I would expect to die. So I'm going to do that. I'm going to go over here and say copy. And I'm going to go down here and say paste. Okay, oops. Problem, right? Why'd that happen? Because they're in the columns and SPSS didn't like that. And I got to do something about that. So I'm going to go in here and I'm going to say paste special. And I'm going to say don't paste the formulas, just paste the values themselves. Up, there you go, worked. Now I don't have that problem. So now I'm going to calculate how many female deaths I would expect in each age group. And it's going to be the population times the proportion of the population I would expect to die in that age group. And now we have 283 there. I'm going to copy this down. And the total I would expect to die is going to be equal to the sum of all of these deaths. Okay. You could tell this is calculated because, these decimal places, where this is actual data, and it's actual real numbers. Okay, so at any rate, how about the age-specific death rate for males? Well, I'm going to take the age-specific death rate for males. I'm going to copy that. And I'm going to paste it in here for males. And then again, I'm going to hit right click, and I'm going to go to paste special. And I'm going to say just the values, please. Paste them in there. Now I'm going to calculate how many males I would expect to die in that age group. So it's going to be the population all the way over here times the rate at which we would expect males to die. Okay, now I'm going to do that for each one of these cells. And we get that, and I'm going to take the sum of all of these numbers. Okay, so now I'm going to go in here, and I'm going to say the age-adjusted female mortality, age-adjusted mortality rate for females due to cardiovascular disease. And that's going to be equal to the number of deaths divided by the population I'm applying it to times 100,000. Okay, and it came into 371. See what it turns out to be for males. Equals this divided by the population again. Close parentheses, the parentheses up here, and times 100,000. Okay, hit enter. And all is right with the world, and men are dying faster of cardiovascular disease when it's applied to the same population. Right? When you take away the confounder. So when you see the data is adjusted, I'll give you an example, and we're done. By the way, as soon as I give you this example, you can hit the silk when you see for instance, if we did a study that examined diabetes, the rate of diabetes in all 5 boroughs, right? Let's say that we oversampled, we did a survey one way or another, and we took 100,000 people, randomly sampled people from each borough. That's wonderful. That's very nice. Except that 3 million people live in Queens, 2 million live here, and 1 million in Manhattan. They're different populations, they're different boroughs. If you're interested in ethnicity being involved, well, when you sample Brooklyn and you get back your random sample of 1,000 people, if Brooklyn is 30% Hispanic, was 30% of your sample Hispanic? Or maybe it wound up being only 20%. So they're even though you took a random sample, they turned out to be underrepresented in your sample. Well, maybe now you got to think about, I got to adjust that so that the influence of being Hispanic is greater in that sample in order to make the data more realistic in representing the population. So sometimes you have to do this. And in this case, we saw that if we just looked at the raw data, it looked like men were dying faster cardiovascular disease than females are. They are, but it's only because there are so many more older women in age groups where the death rate from cardiovascular disease is so much higher than it is at other age groups. Make sense? Right? So that's just kind of an introduction. If you see unstandardized data and you see standardized or adjusted data, now you know what's going on. Somebody has had to fix that data so it's more representative of what the population is. Okay, so let's call it a day. Okay, any questions? Are we okay? Are we okay? I mean, okay, are we okay? Yes, no? We're okay. Okay, good. All right. That answer doesn't have to be the same to that question every week. Next week we're not okay. You can tell me next week we're not okay. Okay, good. Good night, guys online, or good afternoon.